Hello, we are TerraVision, a team of 6 junior CS majors at Georgia Tech aiming to develop a tool to aid the discovery and extraction of geothermal energy. Before we get started, we'd like to introduce ourselves.
I'm Alex Yang, a junior proficient in JavaScript, Python, and Flask, and now Vue.js. I'll be working on the backend and front end of the application.
Hello, my name is Alexander Price. I am a third-year CS major. I am proficient in Java, Python, and C, and I will be working on the front and back end for this project.
Hello, I'm George and I'm experienced with Java and Python. I'll mainly be working with the logistics and backend for the project and any machine learning models we wish to implement.
Hello, I'm Evan McKinney. I'm proficient in languages such as Java and C, and I will be working mostly on the back end.
Hello, I'm June. I'm proficient in JavaScript and HTML, so I'll be mainly working on front end.
I'm Jonathan, and I'm fluent in Python and C, and I'll be working on machine learning and backend applications. As the world continues to develop, there is an ever-increasing need for renewable energy. In many places, one of the best sources of renewable energy comes through geothermal power, in which the heat of the earth is harnessed to produce energy. Our goal in developing this dashboard is to streamline and simplify the process of finding optimal locations for these power plants. Typically, an engineer or scientist would need to parse through many data sets and documents to examine the potential for a location. Our application will compile all of this data beforehand and present it in a graphically intuitive and interactive way. This will also allow people who aren't necessarily experts to gain insight into geothermal power. Our team is working with our client Junaid Saeed of SLB to develop this application.
For our user research, our client attempted to cold email geothermal experts within the company but received no responses. Because the client couldn't give us contact info, we also couldn't cold email these people. More research is needed next semester. Instead, we sent out a survey to potential clients within the company and found that ages ranged between 24 to 50. They had little technological experience, and they mostly consisted of SLB employees and clients working together to add new geothermal plants to the grid.
Here are the additional findings we found during our user research. From the survey we sent out, we found that the knowledge of our user base would be very broad, as can be seen in Figure 1. This means that the application shouldn't be overly complicated since most users will not be experts on the subject. Other notable information that we found from the survey included what the users wanted to know and where. We found that the most important information the user would like to see involved the amount of power the plant can output and viewing multiple simulated power plants in tandem. Our dashboard will also need to be able to simulate information internationally. Some responses of desired locations include Europe, Southeast Asia, South America, and states in the US.
The purpose of our project prototype is to showcase the minimum functionality of the tool we are designing for SLB. This tool is meant to assist in determining where potential geothermal plants should be placed. In our first figure, you can see our main screen. Here we have a map with a color overlay to showcase geothermal potential. Red shows higher geothermal potential and green shows lower geothermal potential. You can also zoom in and out and adjust the opacity of the colored overlay. In our next figure, you can see the ability to add and remove power plants. When adding a power plant, you must input the depth at which the power plant will be located. In our third figure, you can see what kind of information you will get from the simulation of a power plant you have added. For example, you will get the emissions saved, the active temperature, the activity, and the predicted power output. Lastly, in our fourth figure, you can see the location selector where you can select a location like a city and simulate a power plant there.
We encountered a couple of issues from a prototype testing. Testers reported confusing UI elements, not enough information on functionalities, and not the best distinguishable components. The major issues were related to Figma's interactivity limitation, which can be resolved later with actual implementations of products. Other minor issues have been fixed through relocations of buttons and placing tooltips for detailed guidelines about functionalities. We are currently working on further UI/UX testings with SLB employees who will be using this application.
So for our current plans, we are going to develop our product using agile methodology. So we've split every functionality we wish to implement into 5 sprints of 3 weeks. So for example, our first sprint, we want to be able to have basic map interaction and usable buttons set up. So for example, stuff like selecting the location from the drop-down, having the hexagons display the geothermal potential, and being able to view existing plants. And for a minimum viable product, we want that to have geothermal data integrated, and we want to be able to view prospective geothermal power plant outputs. So we hope to be done with the minimal viable product by the end of sprint 3. And then after that, we'll be working on the stretch goals, which will have stuff like you'll be able to select multiple power plants, and maybe we could implement having a machine learning model, which will help determine the geothermal potential of a certain specific area.
For our tech stack, we chose Python Flask, Vue.js, and MySQL. Python Flask is easy to set up and has the added benefit of many of our members knowing Python. It also works well with MySQL and is easy to use for single-page applications. For our front end, we chose Vue, again because it's easy to use. Some people know JavaScript and is efficient for developing single-page applications. And for MySQL, it's not as easy to use as Vue and Flask, but it's secure, which is important when handling sensitive data like SLB has for its geothermal data. It's also lightweight and relatively lightweight and easy to set up. For our tech stack, we chose Python Flask, Vue.js, and MySQL. We chose Flask because it's easy to set up, and many of our members know Python. It also works well with MySQL and has the added advantage of being efficient for single-page applications. For Vue.js, we used a similar reasoning. It's easy to use and set up, and good for single-page apps. And for MySQL, it's not as easy to use as Vue and Flask, but it's secure, which is important for handling sensitive geothermal data that SLB could provide. For our current progress on our front end, we have basic map interaction like zooming, panning, and using the scroll wheel, plant selection and deletion, and the viewing statistics of different plants that are selected. On the data side, we consolidated shapefiles compiled from multiple sources around the web, including the temperature 500 meters below the ground, the 2015 electricity grid, and current geothermal plants, converted those files to CSV in order to read them into machine learning models, and visualize them individually.
The main features implemented are the map interactions and the ability to add and remove power plants to the map. There is currently no overlay of the potential and subdivision of the map because we want to create the most basic features needed for the project, which is the map. The map is the canvas which we'll create art upon. We won't be able to build upon the project without a suitable foundation. Here's the actual app. As you can see, we have a map that we can pan around in and zoom in and out with either the mouse or trackpad. And there's also the plus and minus button in the top left. Currently, we can add plants with this add plant button, which modifies the cursor with this blue bubble, and wherever we click, a plant will be added. As you can see, we can add multiple plants onto the same map, and whenever we select the plant, it is highlighted in yellow and the information is provided on the right. The data we have is currently not integrated with our app, so this information won't be the accurate representation of what will be provided. The other feature also implemented is the delete plant button, which just removes plants that we no longer want.
For our tech stack, we used Vue.js, front-end framework that integrates well with single-page apps. We also used an API called OpenLayers, which is specifically designed for geographic interaction like this. Additionally, we have data about the geothermal information around the surrounding area, but it's not integrated yet. We actually used a plugin called Vue OpenLayers, which is specifically designed to integrate both APIs together.